So, in this program, we are going to see what is the importance of the mutex protection for the synchronization purpose. So, actually, we are working with the program named nomutex.c, where the two global variables, variable 1 and variable 2, are updated by every thread. But when we run the program with just one thread, so when we see here, we have only one thread. So, when we run the program with only one thread, everything works normally. So, let us see how we are going to get that. So, let us clean that project. So, actually this program, it is there in the process thread. So, clean the project and then build the project. And then in the binaries, go to the no mutex, run as. So, now see that we are getting the output as thread 2 did some work. Okay. So, continuously we are getting this. So, there is no problem with this program whenever we are executing the number of thread with only one. So, everything it is working well. But let us increase the number thread to 4. So, here in this program what I am going to do means increase the number thread as 4. So, let us observe how the behavior has been changed. So, give Ctrl S and then again clean the project, then build the project, and then in the binaries go to the new mutex and then run the program. So, now when we observe what we are getting here, we are getting the thing that variable 1 is not equal to variable 2. So, this happens because multiple threads are accessing and updating the same shared variables simultaneously. So, causing the race conditions. So, the threads get preempted in the middle of updating one variable, allowing other threads to modify the values and break the consistency. So, in order to fix this problem, we have to use the mutex. So, let us see how we have to use the mutex in the program. So, when we observe the no mutex program, we see that this is the portion where it is a critical condition where we are checking whether the variable 1 is not equal to variable 2 or not. So, this is the place where we are going to introduce the mutex condition now. So, wherever we are feeling that it is a critical condition, there only we are going to use the mutex. Go to the file, new Qnx project, Qnx executable, then give next, give the language as C, x86-64 as CPU variant, and then finally finish it. So, for giving the project name, let me use it as mutex sync, mutex sync 1. Okay, so this is my project. Let me finish that. So, new project has been created. So, here only I am going to give the new program. So, when we observe the program, so in the update thread only I am introducing the mutex lock followed by mutex unlock. So, mutex before, that is we are locking the mutex before entering into the critical condition, the part where the shared variables are checked and updated, and then we are unlocking it immediately after so, such that other threads can proceed. So, this ensures that only one thread at a time updates the variable 1 and variable 2, preventing the corruption. So, adding a mutex slightly affects the performance because threads now wait for each other, but it guarantees the correctness and eliminates the race condition. So, now let us run the program. So, build the program. Before that, clean the project and then build the project. So, under the binaries we have this. Let us run that and see what we are observing here. So, first of all it is starting, that is creating the threads. So, let us wait for the program to complete and execute it. So, now what we are getting, all done. So, the variable 1 is given and variable 2 is also given. Okay. So, this is the program what we have required here. So, whenever, even though when we increase the number of thread, see here the number of thread has been increased to 4. even though the variable 1 and variable 2 is executing properly and we are getting the proper output. Why? Because this is the critical condition where we are going to introduce the mutex lock. Okay. Thank you.